everyone. I hope you're having an amazing day. So today I'm going to talk about dynamic polymorphism. So if you haven't watched my previous episode on static polymorphism, I would highly encourage you to do so because today's episode is a continuation of the previous one, right? So the first thing first, I would highly encourage you to register for an org if you haven't done so. So I trust you guys have done that. So I've logged into my org. So let's jump into developer console. Okay. So the way to go to developer console, go to gearcog icon at the top right hand corner and go to developer console. So it will take you to developer console. Okay. So this is the class which we've been working on in our previous episode, right? And as well as previous to that when we talked about objects and classes and objects, right? So we're going to use the same class here. Okay. So I wanted to, before I talk about dynamic polymorphism in details, I wanted to cover a topic called inheritance, right? This is a very important concept in object-oriented programming. You should understand it. So inheritance, think about a father and son relationship, right? A father will have certain quality, right? Father could be a musician. Father will have, certain appearance. So for instance, let's say a father is a Latin American, okay, person of Latino origin, right? So obviously if a son born to a Latino father, provided the mother is Latino as well, the kid will be Latino, right? So a kid has inherited the quality of a parent like, through the gene, right? The ethnicity, right? A Latino ethnicity. I know that this is a very bad example, but just to make it very clear, okay? Just to make this concept very clear, a father could be let's say, might have, could be a singer, right? And whereas the father's father could be, his father could be a singer, and his father could be a singer, right? And so it might be possible that kid might have inherited that quality, right? A kid might be a singer as well, right? So you can see that there are certain things that a kid inherits from the father, right? And another thing is the property inheritance, right? Father will, give the property to the child, so the child will inherit the property from the parents, right? But along with that, it is also possible that child will have its own property, or in other words, child will have its own personality, right? So it's not only the case that a kid will only resembles exactly like what the parents been doing, right? The kid will have his or her own personality, right? A son will have his own personality, right? Which could be a bit different to his father's personality, or could be possible that he has absolutely imitated everything what his dad used to do, but along with that he has, he got other habits as well. So that is something a concept of inheritance is about, right? Or in simple terms, if you still find it very difficult, think about a property inheritance, right? That's a very simple example. Your father owns a property. Let's say your father owns $1 billion worth of assets, right? And when he dies, that you inherit that $1 billion worth of asset. But along with that, it might be possible that you would have created your own extra billion. So that means your father's property plus yours, so $2 billion, right? So you have inherited plus you have added something, right? So that is something what we're going to do today. So the way we're going to do today is that we're going to work on the car class, right? As you can see that a car class is a basic blueprint which defines what a car can do, right? Car can drive, right? A car can has different properties like name, model, number of doors, right? Now let's say I wanted to build a flying car using this model, right? I wanted to build a flying car. So most of the stuff it will inherit from this main blueprint, right? It will have a model number, it will have a number of doors, it will have a name, right? It could be XYZ, flying car, and it can drive and fly, okay? Or it can, so let's say the flying car, in flying car terminology, when you say drive, it does drive and fly together, okay? So that is exactly what we're going to do today, right? So in this case, right, as you can see that we have something called public void drive. Okay, so what I'm going to do, I'm going to make this function as a method as virtual. Let me save it. So when you define a method as virtual, what that tells you is that this method can be overridden by a child class. I know that sounds confusing. I'm going to show you what exactly I meant by that. Okay, so as I said, that this is a base class. Okay, forget about the base class. This is a main class. Okay, car class, main class, right? Which is like a blueprint. Okay, a simple blueprint. We're not going to do anything with it. So all I've done, I have defined a method called drive virtual. That's all I've done. For now, keep that into mind. We have defined this method as virtual. Okay, that's cool, right? Let's create another class. Okay, so let's create an Apex class. Okay, so let's say we want a flying car. Okay, I mean, it will be possible, right? It's just a matter of time where we have flying cars, right, which can drive on the street as well as fly. Okay, so a flying car. Okay, now what I wanted to do, that I don't want you to write all this code here, right? This name, this constructor here. I don't want it to drive all of this. I don't want it to copy and paste the same code. I don't want it to do that because it's just a duplication of code. And plus, I wanted to use the concept of inheritance here, okay? Because as you can see, that car class is a general class blueprint, right? And whatever a car can do, all of the stuff we have it here, right? The model number, name, everything here. So why do we have to duplicate the code, right? Why do we have to, repeat the same thing here and here, right? So to solve that problem, what we're going to do, right? We're going to inherit it from this class, the car class, okay? So what we're going to do, we're going to do extends. So the copy place, okay? So let me extend it, okay? And I'll show you just a simple behavior. It just, okay, hang on. I might have, let's see. Okay, sorry. Just bear with me, okay? Just bear with me. I'll explain to you what I'm trying to do, okay? All right. So what I was trying to do, okay, in this case, right, I wanted to make this class as a base class, okay? So the reason why I intentionally do that in the beginning here, just to show you what happens, okay? So as I said that I made this class virtual, right? Okay, I made this class virtual. Sorry, I made this method virtual, right? That's fine. But to inherit it, right, you have to make this entire class virtual, right? That's because when we talk about inheritance, right, you have to do this. Otherwise, it will not work. Say, if I don't do this virtual here, okay, let me save it, okay? I'll give you exactly what's the error, okay? And then we just modify it and just save it, right? It will error out. So, non-virtual and non-abstract cannot be extended, okay? So you can't extend it. You can't inherit a non-virtual or abstract class. Abstract class, don't worry about it. I will cover that in detail, okay, in the next episode. Right, so we have to make it virtual, okay? Now, there's another change I've done, okay, if you remember. That, let me close this, okay? Let me comment this one, okay? So When you define a virtual class, right? Okay, so let me save it. So the problem here happens here, okay? So in this case, right? So if you are defining just like this, okay, no change, it is complaining that the constructor what you have defined, right, here, there's no default constructor because you have created your own constructor which passes the value. But here in this class, there is no default constructor, okay? So to solve the problem, you can add a default constructor. Okay, but I'll tell you there's a workaround for it, a better one, but for now, just add a default one. So this is the default constructor, okay? So which means, if you remember, you create a class object, object name equals to new class, right? So you don't have to pass anything here. It's just the default constructor here, okay? Now it will let you save it, okay? Right? Now, so I have inherited this, okay? Now I don't have to write any of this stuff here whatsoever. I don't have to deal with, you know, any of this stuff whatsoever. And I don't have to deal with any of this method here, okay? So can I access this method? Let's say I wanted to access display info. Can I access it using this specific class? Absolutely. Okay, I'll show you what happens, okay? So we're gonna do flying car, f equals to new, okay, flying car. All right, so what we're gonna do, so we're gonna do, let me look at the constructor here. We can type od, oh, come on. Okay. Oh, come on. All right, just a second. I think I'm mucked up. Control Z. Yeah, it's a bad practice. Sorry about that. It's just been a long day today, so okay, that's right. Right, now let me go back to here. I'll try not to muck around. So model number, number of doors. Okay, so what we're gonna do, gonna go here. So I'm gonna close it here. I'll just say flying car. Flying car. That's new. Flying car. Okay. Just gonna do Audi. So we're just gonna say the model number, blah blah blah. Okay, and we say 2. Okay, the number. So let's see first of all whether this code runs or not. Okay. Right. Now, see, there is a problem here, right? So now the problem is, see, this is the reason why I'm saying let's see the code runs or not. See, what happens is constructor not defined, okay, because there is no constructor here, right? So obviously it will not accept, right? It will not accept this parameter because there is no such thing defined here. So what? That's the reason why you got that error message, right? There is no default constructor defined here, right? So if you do something like this, right, it will work, okay? Now, so what we're gonna do, let me do this, okay? And flying car, okay, and I'll just say base, hopefully. Right. Just wait, bear with me. Okay. All right. Now, you see the difference now? What happened? I don't need this default constructor because what happens is that it expects you to define your own constructor here. Okay. Just pay attention here. I know this is a bit wacky and a bit complicated concept if you're new to object-oriented programming, and my intention is not to complicate it. My apologies for that, but I wanted to explain to you dynamic polymorphism. It's a very, very important topic, so stay with me. So what I've done, okay, as I can say that flying car inherits, okay, car class, okay, so inheriting a property, okay, but the thing is that since I defined this constructor, okay, I've decided to define my own constructor. So inherited class expects you to define similar constructor of this type, okay? So I have to define similar constructor, okay, as you can see. But you see the super code, right? When you put super, it means that you are referring to the parent class constructor or parent class, right? So here I'm telling put super means call the parent constructor. Super in inheritance in Apex, it means you're referring to the parent class, okay? So in this case, when you say super here, you are saying call the constructor of this one, okay? You're saying inside this, you're saying, okay, please call this one, okay? So I know this is a bit confusing, so I have to define a constructor for this flying car. The reason why I have to define it, because you have already defined a constructor for the car class. When you inherit a class, right? Let's say you have some other class, right? You are inheriting, let's say, bus class, okay? And if the bus class do not have this constructor, right? This public bus class, and right, you don't have to define a flying car constructor specially. The reason why you have decided to, write your own constructor, so whatever class which inherit the parent class, right, has to define a constructor. Otherwise, you have to, if you don't want it, you have to define the default one, what I mentioned here, right, which defeats the whole purpose, okay, right? So now if you save it, and now let's say if you go and debug it, and if I say OD, okay, and if I say model number and number of doors, and if you execute it, it works, no problem, right? It works with no issues, okay? Now, can I access this? Okay, let me save this one. Can I access this, what's this called? Display info? Because I haven't defined the display info here in this method, right? In this flying car. Can I access the display info of the car class using this flying car? Let's find out. Okay. So what we're going to do, f dot flying display info. Okay. Absolutely, it works, right? So what does that tell you? It tells you the flying car can access the properties of methods of the parent class. It's like a child can access, child will have some qualities of his father, exactly, right? So think about a car class as a father and a flying car as a child. So the car class, which is a father, has a feature called display info, right? So obviously the flying car child inherited that, feature, display info. So when a child called, f.display info, it displays the information, okay? Now, coming to the actual topic about dynamic polymorphism, which means that, if you remember what I talked about polymorphism, right? One name, many forms, right? So what does that mean? It will be actually applicable here, okay? So now, if I say drive, okay, right, it will display you drive, okay. Now that is not dynamic polymorphism exactly. What if I wanted to display flying, driving and flying instead of just drive? Can it be done? Absolutely. That is why we have defined virtual here. Means any method which you define as virtual can be overridden in a child class, okay? Any method which you define as a virtual in a parent class can be overridden in a child class, okay? So let me copy this code here, right? Okay, and I will die a keyword override, right? Right. So I've done override, okay? And instead I can say drive and fly, okay? I'll save it. So now, this is where the real dynamic polymorphism comes into picture, right? Your code is deciding at the runtime which method to call rather than deciding at the compile time like we did for static polymorphism, where we have to select the code before you run it, okay? So in this case, you don't have to select, which drive will run, right? Your code or your compiler will decide at the runtime which this information to be displayed, and right. Okay, so let's go to debug. Now think about it for a second, okay, what I've talked about it right now. So what I've said, that when you talk about dynamic polymorphism, right, you are choosing a method at the runtime, okay? So that means one name, many forms. A drive is a one name, but it can have many forms. Many forms in the sense it can drive or it can drive and fly, okay? So one drive can only drive, one drive can drive and fly in terms of flying cars, okay? So now in this case, I'm just calling a method drive, right? So drive and fly, right? Sounds simple, right? So now you must be thinking, what the heck this guy just did? Okay, so this is another concept. I don't want it to complicate this stuff for you guys, but so what I'm doing is that, okay, okay, I mean, I don't really want to complicate this, guys, at this stage, but this is just one of the concepts, okay? Okay, for now, or forget about it, okay? So think about it for a second, okay? A dynamic polymorphism, right, and static polymorphism is that static polymorphism will where the compiler will let you choose a function or a method at a compile time, okay? In dynamic polymorphism, a compiler will let you choose a method at a runtime, okay? Like in this case, right? I don't have to tell the code, hey, choose the code of a child class, okay? Because here in this case, right, class, car class. So what I'm doing here in this case, right, a very simple case. This is a little bit trickier concept for you to understand. So I've defined a child data type as the parent class data type, right? But instead of saying new car class, I'm saying a child, right? Let me show you something else. Okay, let me show you something interesting. The reason why I'm teaching you all this stuff, I just don't want you guys to know just Apex, syntax around Apex. That's just not good enough, because you guys need to understand object-oriented programming. Apex is an object-oriented programming, and you will be doing injustice to Apex if you don't understand Apex as an, if you don't use Apex as an object-oriented and instead start using it as a procedural language. That will absolutely defeat the purpose, right? Okay, so you see the difference here? Okay, so let me explain it in very simple. Okay, so in the first case, okay, I can assign a parent class an instance of a child class. Okay, so I can say car class is a parent class, and I can say, okay, let me initialize with a child class. Okay, this will work, but I can't do the other way around. Okay, so where a parent class, so this is the child class, right? And I can't do new instance of a new parent class. It doesn't work. So this condition will not work. Okay, so you can always start with the top, right? You can say, it's like a top to bottom, right? Let's say top is your father or grandfather. Think about, normal human point of view, right? Because if you don't understand, if you find it very hard to relate from a code perspective, think about a family tree, right? Where you have grandfather at the top, then father, or grandmother, or whoever it is, right? Okay, or your mother, and whichever tree you wanted to follow. Okay, so let's say grandparents at the top, okay, and then comes the parent and the child, the grandchild. Okay, so this is how you can see the grandparent. Okay, then you can say equals to new parent. Okay, which is top to bottom, right? In this case, what you're trying to do is you're going from bottom to top, right? You're saying a parent equals to a new parent equals to new grandparent. Doesn't make sense, right? So that concept doesn't work. Okay, so you can close this part of a code, so because it's not going to work. Okay, so this is why I said, I'm actually calling a parent class variable dot drive. Okay, because obviously it's a car class variable, right? C dot drive. So you would assume that, oh, okay, it should say drive, but instead it prints drive and fly, because in the runtime it's deciding what to call, right? It's actually choosing the child method. Okay, because a parent is doing a job of a child here, in this case, in simple terms, right? A child comes to a parent that says, look, Pa, can you do this stuff for me? Okay, so when you see a parent dot drive, it means a child is driving. Okay, that's the simplest way I can explain. I mean, I don't know how to explain more simpler than that. Okay, so it's like you're a parent, you're sitting there with a variable name in your hand, and your child comes to you and says, look, this is my instance. Okay, and then your pal say, okay, that's great, right? So then you say, a parent dot drive. So obviously, it's like it, fly and drive, because it means that it has to call the child drive, because that's what's happening here, because the child came to you and said, look, you please drive for me. So that is exactly what you're doing. A parent is driving for a child here. But other way around is not going to happen, because it doesn't support an object-oriented. Where a parent comes to a child, let's say, think about a 6-year-old son, right? If your father comes to you and say, look, hey, can you drive for me? That's illegal, first of all, right? So that's what it is, right? But on the other hand, a parent comes to you a child comes to a parent and say, look, Park, or Dad, can you drive for me? Okay, so that's legal and that's gonna happen. Okay, so you're driving for your kid here. Okay, so that's drive and fly, right? So it's called flying car instance. Okay, I'm sorry, this is the best I can do to explain this. I know that it's tricky. I would highly encourage you to um, read about object oriented, right? You can read using any language, Java, .NET. Concepts are similar, right? Okay, so yeah, that's how the concept of dynamic polymorphism comes in the picture. Okay, and it's very useful. It's very used, right? I've used it a lot of times. Okay, so I hope you guys enjoy it. Whatever I taught you today, that's all I wanted to cover. So greetings and adios. Take care.